So we're here in Pfizer's pilot facility in Andover with Mark, who's going to talk us through what happens at the beginning of downstream processing. Mark, thanks for taking the time to talk to me today.
You're welcome.
So let's just start with a simple question. What is it we're standing in front of?
Well, this is a continuous flow disk stack centrifuge. So it's used to harvest cells from the bioreactor. It uses gravitational force to separate the cells from the media. So the idea here is to remove the cells while keeping them intact. This is 8,000 times the force of gravity. So.
And you don't rupture cells at that
No, surprisingly not.
That's pretty impressive. So what is it inside this centrifuge that allows us to separate the cells and keep the supernatant from the bioreactor?
Well, it depends on something called the disk stack, which is a stack of disks. And basically what it does is it directs the outward centrifugal force downward into a centrifugation space, a
so
sediment
this
space.
This stack is going to be sitting inside the centrifuge just like this.
That's right. There's one just like this sitting right inside there.
And it's going to be rotating like this, and the cells are going to be forced to the outside, and they're going to hit the sides of the centrifuge and sort of go down until they hit the wall.
They run right down these plates, and if you look carefully, there's spaces in between these plates, very small ones, but big enough for a cell.
So how big can these things get? Like if we're going to go to a commercial facility, how big is your centrifuge going to get?
Yes, we have one next door for the 12,000 liter reactor that's about 12 times the size of this in every aspect.
When you're transferring like the process from this centrifuge to the one that's 12 times larger, what do you need to keep in mind?
Well, it all comes right back to the disk stacks. So basically, the number of disks in your stack, the angle that they're at, the amount of area there is, the radius, all goes into something called a sigma value, which is the separation power of the centrifuge.
Yep.
Now, what the scaling factor is the throughput flow rate in relation to that separation power. So by going at a slower flow rate, you're going to have more sigma in relation to your throughput.